All right, so we're back for the last set of these notes here for chapter 9, factoring. We're looking at factoring harder trinomials today. Excuse me. So if you remember, we called the other ones the easier trinomials because trinomial has three terms, and the ones we did earlier on during class last Thursday always had a 1 in for a. So they all started with x squared. If they started with another number here, that ended up being a GCF that we could pull out. So then in parentheses, we still had an x squared with a 1 in front of it. And so we knew when we factored those first terms in each binomial would be just an x. X times x gave us x squared. So now we're going to do harder trinomials. So an example of what that might look like might be 3x squared plus 4x plus 8. Okay. Now, I don't know for sure. I just made that up, so I don't know if it's factorable. So don't try to factor that. We have plenty of other examples moving forward here, but this is just an example of we have ax squared plus bx plus c. This time my a is not 1, and it's not a GCF. I can't take a 3 out of all of these. So I couldn't break it down anymore. Okay, so before we get to the factoring, let's start the way we have for these other parts also, and kind of start by reviewing the multiplying, because that's also going to tell us why this is a little bit harder than the other type of trinomial that had a 1 in front of the x squared. So let's go ahead and multiply 3x plus 1 times x minus 4. So we get 3x times x is going to be 3x squared. 3x times negative 4 is negative 12x. 1 times x is plus 1x. And 1 times negative 4 is minus 4. So when I combine my like terms, my negative 12x and my 1x, I get negative 11x. And then I have my minus 4 on the end. So let's just kind of break this down and take a look at it as we did before. So we see that we ended up with a 3x squared here. We do not just have a 1 in front of the x squared. Why do I have this 3? Well, it's because this term right here was not just x, it was 3x. So 3 times that 1 gave us the 3. Now, just like before, the 1 here and the negative 4 here, those two multiply to give us negative 4. Just like before. So we had two numbers that multiplied to give us those two. However, here's the difference, right? 1 and negative 4 multiply to be negative 4, but they do not add up to be negative 11. Okay, why not? Well, previously, when we just had an x here, when I take this number and multiply it by x, that number becomes my coefficient. Well, that doesn't happen anymore because now my negative 4 is getting multiplied by 3x. So that's not having a negative 4 as its coefficient. It's having a negative 12 as its coefficient. Okay, so I cannot, with these harder trinomials, I cannot find two numbers that multiply to this and add up to this. It doesn't work that way anymore. I need to find two numbers where, my last two numbers, where this, they multiply to this, but the product of the outers and the inners multiplies to this, or adds up to this, sorry. It has to be, has to take this 3 into account, right? This 3 kind of doesn't change the end, but it changes those middle terms. So there are two ways we can do this. We can work with trial and error, meaning we kind of make educated guesses. We don't just guess totally random numbers, but we make educated guesses about what numbers would help us. Or we can also use what we call the AC method, which is a series of steps that's going to get us to the right answer without having to guess. So if we were going to use trial and error here, okay, then I might say, well, okay, this is a trinomial. I know that it's going to factor into two binomials. So I need something that multiplies to 3x squared. Well, luckily for me, the only way to make 3 is 1 times 3. So I know it has to be 3x and 1x, or it could be the other order. Now, to make 4, I could either have 1 and 4 or 2 and 2, and it needs to be negative. So I could try 1 and 4, I could try 2 and 2. This being negative means these two signs have to be different. Now this time it's not quite as simple always as saying, because this is negative, the larger of these numbers has to be negative. But it's the larger of these two, which come about when you take this number and multiply it by that. Okay, so it's not always the larger of these, it's the larger of the products. So let's pretend I tried one time and I tried, okay, +2 and -2. Well, what happens now is that I get 3x times x is 3x squared minus 6x plus 2x minus 4. So I would get 3x squared minus 4x minus 4. And as I said to you before, here's what often happens. Your first term is correct. Your last term is correct because you chose numbers that did that. It's your middle term that's not. Okay. We could even change these signs because that would make a negative number being multiplied by 1 and a positive number being multiplied by 3. That would change these signs. It would be positive 4x. That's not what we want either. And then with 4, we have 1 and 4. And putting them in different orders in this case makes a difference because whatever's over here gets multiplied by 3. Whatever's over here gets multiplied by 1. So you can see that even just in this case where 4 does not have a lot of factors, trial and error, we would get 4 different options we'd have to try. Actually, really more than that because I could have 1 and 4 in either place and I could have the positives and negatives switched around. Now imagine what if my first number was like 12 and my last number was 24. Think about all the factors I would have, right? I could have 1 and 12, 2 and 6, 3 and 4 here and here. I have to try all those options, and I'd have to try 1 and 24, 2 and 12, 3 and 8, 4 and 6, all of those options. And then if I have negatives here on top of that, I have to get the negative sign in the right spot. So trial and error works. It is pretty useful if I have something where the first and the last numbers are primes. There are not a lot of factors. But sometimes it takes a little bit to get your answer. So we're also going to learn this AC method for factoring. Okay, so I have an example over here. So I have the steps here and an example next to it. Then we'll do a little something different with that example. Then we have one other example to go through. Okay, so the first step is that we multiply A times C. Well, what do A and C mean? Remember that we can call this AX squared plus bx plus c, right? That's our format of a trinomial. So a is 4, b is -5, c is -6. So I want to multiply a and c. You can see that I wrote out what I had here. A is 4, c is -6. So 4 times -6 is -24. Now, this is where it gets similar for this step to our easier trinomials. We want to find factors of AC that add up to B. So instead of just finding factors of the last digit and say they have to add up to this, I'm looking at factors of this product and they have to add up to that middle number. So in this case, 4 times -6 is -24. I need numbers that multiply to -24 and add up to B of -5. So I could put out all my list of factors of -24. They want to add up to a negative, so I know I need to have more negatives. Once I do that, I find that 3 and -8 are my two numbers. So 3 plus -8 equals -5. 3 times -8 equals -24. That's the magic set of numbers that's going to help me in this case. So now 3 and -8 do not go into your binomials at this point, okay? Because I don't want 3 and -8 in the last places because I don't want -24 here, right? We have to kind of figure out how those influence our factors. So here's where there's something a little bit new. We rewrite the trinomial with b of x, this middle term, as the sum of two terms using the numbers you just found as their coefficients. So I found 3 and -8. So 3 plus -8 we know adds up to -5. I'm just splitting that into two things that add up to it. So 4x squared plus 3x minus 8x minus 6. means exactly the same thing. And if you remember, this is kind of the step that we came into on our factoring by grouping. Let me just scroll back there for 1 second. And if you remember, I said here and here, yes, these middle terms would combine, but just kind of trust me for now that we want them separate. That's why, because we're going to use factoring by grouping now once we've separated these. So in this case, I looked at these two. What these two had in common was only an x. I took an x out of both and you get 4x plus 3. For these two, what they have in common is -2. And we get 4x, this is a typo, that should be a plus right there. It should be 4x plus 3, right? Because -8x minus 2x is positive 4x. -6 divided by -2 is positive 3. Once again, I see that these two are the same, comes out as my common factor. And then what I have left is x minus 2. Again, I can check it by multiplying. So if I check it by multiplying, I get 4x plus 3 times x minus 2. 4x times x is 4x squared minus 8x plus 3x minus 6. Well, these two, I always want to check. Yes, they actually do add up to -5. So 4x squared minus 5x minus 6. Okay, so I would suggest pausing the video for a minute, kind of going back, making sure you understand all of the steps of this example. Okay. Once you have done that and you're comfortable with how we got to our answer right here, our factored form, then you can move on to the next part here. All right, so I want to address one thing that we did in here. When we got our numbers 3 and -8, as those are the numbers that are adding up to -5 and multiplying to -24. And I said, okay, go ahead and rewrite the trinomial with b of x, or bx, sorry, as the sum of two terms, using those two numbers that we had. Well, what happens if I put those numbers in the opposite order? I should be able to, right? Because addition is commutative. So whether I have 3 plus -8 or -8 plus 3 or 3 minus 8 here, either one of these should be the same thing. We know that because of the commutative property of addition. So what happens if I put those in the opposite order? Well, let's see. Here's where we factor by grouping. So what comes out of both of these? Well, I can see that a 4 does and an x does. So I take a 4x out, I have x minus 2. Then I look at these two. What do these two have in common? They have a positive 3. When I take that out, I get x minus 2. Now, if I look at this step right here and let's see, this step right here, they look pretty different, right? I have 4x times x minus 2 plus 3 times x minus 2. Here I have x times 4x plus 3 minus 2 times 4x plus 3. Well, they look very different, but if I look a little more carefully, they're just kind of inversed from each other, inside out almost. So I'm looking at what these two have in common. They have x minus 2 in common. So that's going to be what comes out front. And then I want to write what's left. Well, in this term, once I cancel out x minus 2, I have 4x left. And in this term, once I cancel out x minus 2, I have plus 3 left. So let's take a look at how this example, or this answer, sorry, relates to this answer. If I look, I have exactly the same factors, 4x plus 3 times x minus 2. They're just in an opposite order, which again is fine because of that commutative property, right? This is the commutative property of multiplication, saying that I can multiply two things in either order and I'll get the same answer. And if I check this, I just get things, those middle terms in an opposite order, but this is exactly what I want to have. Okay, so those middle two numbers, once you find those numbers, you can put them in either order as long as your signs are correct and you'll get the same answer. All right, let's go through one more of these. So we have 3x squared minus 11x minus 4. So let's think about those steps. Number one, we want to find AC, which means we're multiplying A times C. Well, my A is 3, my b is -11, my c is -4, right? Ax squared plus b plus c. Bring those signs with them. If you're not sure where these came from, go ahead and stop the video or go back to the last example. You can kind of see where they came from. They come right from the polynomial. Okay, so a times c is going to be 3 times -4, which is going to be -12. So now I want two numbers that multiply to -12 and add to -11, or b. So I can do this the same way I've done my factors before. I can think about what makes -12. Well, to make 12, we have 1 and 12, 2 and 6, 3 and 4. I want it to multiply to a negative. That means my signs have to be different. And I want more negatives. So in each pair, I'm going to make the larger absolute value, the larger number part, negative. Well, these would add up to -1, these would add up to -4, these would add up to -11. So this is the pair I want. So now in this case, I do not put these in my factors. That happens in the easier ones, but now I have to take another couple steps to take that number in front of the x squared into account. So remember now, what I do is I rewrite this, except I stop at that middle term, and instead of -11x, I use my two coefficients that I just found. So +1x minus 12x. Those add up to -11x, and it means exactly the same thing. So now I'm going to use factoring by grouping. I have my four terms. There's nothing they all have in common. We can see that pretty easily with the x's because there's no x here. And 3 is prime, so the only factors of it are 1 and 3. If I factor out a 1, it doesn't help me. 3 does go into 12, but not into these other two. Okay, so 3x squared plus x. What comes out of here is x, and I have 3x plus 1 left. I always suggest at this point in factoring by grouping to multiply these back to double check that you're on the right track. X times 3x is 3x squared, x times 1 is x. Then here I want to take out a negative, I can take out a 4, and I get 3x plus 1. Watch these signs when you pull out a negative. Negative divided by negative is a positive. All right, so now I take what they have in common, and I have x minus 4. Again, we can check it by multiplying. And also at this point, you know that I could have written it in the other order as long as my signs are right. 12 has to be negative and 1 has to be positive. If those signs are switched, then it gives me a positive answer instead of a negative for the 11. Okay, so we're going to now just take a look. We've done all our different kinds of factoring, okay? So right here, I have this little list of factoring strategies, also known as how do I know where to begin, right? You're given a factoring problem, what do you do? Well, the first step is always to factor out a greatest common factor if possible. So you have a greatest common factor, and you'll put whatever's left from each term in one set of parentheses. That's all you'll do first. Then you're going to look at the remaining polynomial, okay? If there are two terms, you want to see if it's the difference of perfect squares. If it is, then it's going to be x plus the number and x minus a number, or term here. If it's three terms, is it a trinomial like this? If yes, if a is 1, you want to find two numbers that multiply to c and add up to b, and those go right in your binomials. If a is not equal to 1, we want to use that method we just learned. And if you have four terms, can you use factoring by grouping? So these are really all the situations that we know how to factor, either difference of perfect squares, a trinomial in that form, or if it's four terms, factoring by grouping. Now, sometimes we factor And then we see that we can factor again. Remember the one in the last video, or maybe 2 videos ago, where it was x to the 4th minus 81. So I took difference of perfect squares. I factored, while this one was difference of perfect squares again. So you repeat this as many times as you need to factor completely. That means there's no more factoring to be done. And then finally, you always want to check your answer by multiplying. Okay, so let's look at some of these. And what I would really suggest that you do at this point is pause the video and try number 1 on your own. Remember to look for a GCF, pull that out, see what you have left, and then see how you can factor it, okay? Try it what you can, even if you don't get through all of it, and then start the video again so you can follow along with me, okay? That gives you a much better practice than just waiting for me to do it. Okay, so let's take a look at this.